We're looking at problem 30.10. They've got an inductor, which I drew over to the right. It has an inductance of 0.260 henries, has a current that goes from right to left. The current is changing at a constant rate, which helps us because it means that when we deal with di dt, we can just say it's delta I over delta t. And they tell us that the potential from A to B is 1.04. And this is actually going to have the higher. They say that A actually has the higher voltage. This one's going to have the lower voltage. Okay. So then they ask, is the current increasing or decreasing? Well, the only way that it's possible for you to get a higher voltage, the voltage, remember, is going to oppose the change in current. So the only way that's going to oppose that change in current is if that current is increasing. So the current has to be increasing. Then they say, if the current at t equals 0 is 12 amps, what's the current at 2 amps? Well, that requires us to actually use Ohm's law along with this. So first, I tried to find out what the change in the current was. So I used E equals negative L di dt. And I know that this 1.04 is the opposite of the change of the current. So I'm going to actually call this negative 1.04 volts because I'm going the opposite way, right? This is actually 1.04 higher than over here. Okay, so I'm going to call it negative 1.04 volts. And it's negative 0.260 Henry. Yeah, I said it. And as I said earlier, because it moves at a constant rate, di dt is going to be the same as saying delta I over delta t. And they tell us that it takes 2 seconds for this thing to happen. So I'm even going to put that in. 260 Henry delta I over delta t. Negative 1.04. And that's, sorry, I'm sure it replaces with 2 seconds. So I'm going to multiply all that stuff out. I get that delta I equals, what is it, like a 2.08 divided by 0.26, which gives me an answer of positive 8 amps. Well, I know my original current was 12 amps, so I add the 8 amps to it. So that means I have 20 amps at 2.0 seconds. I want to point out that if you actually go look this problem up in the book, you're going to get a different answer. I think they put the arrow the opposite way, or at least in the mind of the person that wrote the instructor solution, it was the opposite way. I went back and did the problem 3 times just to make sure I understood, and that really is the only way that it could be true. So it's got to be 20 amps at 2 seconds.